Hello men, today we're going to be looking at how to round correctly when you're doing calculations in a lab. We'll follow slightly different rules depending on if you're multiplying and dividing or whether you're adding and subtracting. In both cases, it's your worst measurement that limits how exact your answer is. Now, when we're multiplying and dividing, we'll find our worst measurement by counting the number of significant figures, or number of Sig Figs. When we're adding and subtracting, our worst measurement is the measurement that has the least specific digit place. So we look at whether it goes out to the tenths or hundredths place or so on. To illustrate this, I'm going to go with a silly but simple example. Let's say we're doing a lab, and the objective of the lab is to determine the area of this rectangle. So I'll take two measurements, the width and the length. If the width measures 7.20 centimeters and the length 12.091 centimeters, then we can do some calculations. We take our measurements, and for area, you go length times width. If you want to pause and type those in on your calculator, you'll find out that 7.20 times 12.091 gives us an area of 87.0552. And since we did centimeters times centimeters, our unit is centimeters squared. The problem with reporting this as my answer is it looks like I have a really great measurement. Look at this. 6 significant figures, like, oh, I really measured this with a lot of exactness. When in reality, my measurements do not go out to 6 significant figures. The length has 5 significant figures in it. Remember, this 0 is a confined 0, which is significant. And the width has only 3 significant figures. Again, this 0 is a trailing 0, but there's a decimal point in the problem, so it is significant. Now, my worst measurement out of these two is the one with only 3 significant figures. So I really only know the answer to 3 significant figures. I have to report my answer rounded after 3 significant figures. So I look and I see that I'm cutting off a 5, which makes this 0 round up to a 1. And I report this answer as 87.1 centimeters squared. Then it is rounded correctly. So we see that it was when we were multiplying or dividing, it was the number of significant figures in our worst measurement that determined how many significant figures we had in our answer. Now for our next example, we'll look at an adding or subtracting example, where we won't be counting significant figures, we'll be looking instead at the digit place. Back to a similar example, let's say we have the same rectangle, but this time I want to know the perimeter. So I'm going to add up all the sides. You can stop and add these up if you want. 7.2 plus 7.20 plus 12.091 plus 12.091. And this gives us a perimeter of 38.582 centimeters. Okay, and this time to determine my worst measurement, I look at what digit place each measurement goes out to. First, I have to see if the 0 on 7.20 is significant. Well, it's a trailing 0, and there is a decimal point in the problem, so this is a significant 0. So this measurement goes out to the hundredths place. That's how exact the measurement was. Whereas the 12.091 goes out to the thousandths place. So you want to say, well, which one's better, which one's worse? A really, really good measurement goes way, way far out to the right and has lots of exactness. Whereas a measurement that's not as good does not go as far out. So in this case, the 7.20 is not as good, and my answer has to round to the hundredths place. The hundredths place. So in other words, in my 38.582, I have to round it after the hundredths place. Since I'm cutting off a 2, the 8 stays down as an 8, and I have to report my answer. The perimeter of this rectangle is 38.58 centimeters. This was similar to the last problem in that I was limited by whatever my worst measurement was. But remember, when I was multiplying and dividing, I was counting significant figures and saying, oh, this has 3 significant figures, this has 5, my answer must have 3. In this case, I wasn't doing that. I was instead looking at the digit place. The 7.20 goes out to the hundredths, the 12.091 goes out to the thousandths. Hundredths is worse, so my answer must round to the hundredths place. And those are the two different cases for knowing when to round.